Hello, you guys. I'm going to show you a little bit about the reference table pages 8 and 9. You should have it out so you could refer to it. Recall that I already showed you eon, era, period, and epoch before when last we were face to face. And I told you I'd tell you all about these other sections later or coming up. Well, that's today, and that's what's going to happen right now. So I'm going to take you now through each of the columns. Life on Earth is the first one. It's, of course, all about life on Earth, and as you may recall, I said that living things came about here, and we see at 542 million years ago, and I said that all of this stuff in white, and if you were in school, you colorize this section, is when we had complex life. So more on that. So you can tell certain things, there's a lot going on, there's small writing, you have things like when the humans came about, mastodons, mammoths, New York State had mastodons. Humans came about 1.8 million years ago. Here's your timeline, here's your timeline, those are absolute numbers. Mass extinction of the dinosaurs, 65.5 million years. These time frames you don't have to necessarily memorize. You don't have to know when the earliest grasses occurred. You just look here. Earliest dinosaurs, all right? And so you could know by number, numeric number, or you can know by saying late Cretaceous or early Cretaceous, the period and epoch. And the earliest dinosaurs are Middle Triassic. Going down a little bit further, you'll see that you have these numbers here, and that is where you can get more fine-grained numbers for anything that happened in the Phanerozoic, essentially, which is the Paleozoic, Mesozoic, and Cenozoic. Alright, that's where you get your fine-grained numbers. I want to focus in on Earth's early corals. The first corals happened way back in the Middle Ordovician, and you would take the time frame, you would pick a number actually, not a range, but between 488 million years ago and 444 million years ago. You can also call it Middle Ordovician. Alright, and we're going to look at the whole of the reference table, and I want you to notice that you don't get a time frame for that early coral by passing through this black line. It's not over here and like billions of years old. Those first corals occurred around, let's say, 450 million years ago. You have your reference table in front of you to refer to. Then going in the opposite direction, all of this information is related to that time period. So what animals existed, is there bedrock that shows that in the state of New York, what were the geological events, and what did the land masses look like at that time in Earth's history. So next I'm going to show you this skinny little column, New York rock record, zooming in closer. Okay, it's often overlooked, it's very thin, and we think it means nothing, but it really is significant, and oftentimes it's referred to in questions. So there's a key here. This indicates sediment, and the dark black indicates bedrock. It shows what rocks or sediments exist in our state in the geologic past, and it's also correlated with page 3 of the reference table, which I'll show you in a second. So where there are gaps, like here, well, here, and a little bit here, and even down here, though that means nothing for that time frame, like in here between Jurassic and Cretaceous. For example, this evidence for this mass extinction between the Permian and the Triassic, it doesn't exist in the state of New York. We know about it from evidence from elsewhere. But most of the and I want to point out that most of the bedrock in the state of New York is in the Paleozoic, which is here. All right, Cambrian through the Devonian. And what I mean by looking at page 3, this is a generalized bedrock geology map. I really wanted to teach you this map more face-to-face because it's a complicated map, but it's an important map. It's my favorite one because I'm a geologist. But looking at this key in a little more closely, you can see the Paleozoic is from all the way here, late Triassic. These are the geologic rock formations in the state of New York, to this tectonic sequence. Those are all the Paleozoic rocks that are considered bedrock. This Cretaceous and Pleistocene, this is what Long Island is made out of. That's what is termed sediments in the rock column. And then this middle Proterozoic, these rocks here are the oldest rocks in the state. Let me go back and show you this. That's this area here, which is the Catskill Mountains, and then a little sliver right here that I can't remember the name of, but those are predate complex life. Okay, so we have some really old rocks and then some really fairly new rocks and then some stuff in the middle. Alright, so we do have, based on those corals, we have some rocks based coral. I'm going to show you for homework. We're going to look at a piece of coral from that time period. Now scooting over one more column to the time distribution of fossils. This is also an interesting column. Alright, a lot going on, but it's based on index fossils for our state. We have 26 to look at. I made a video for your assignment today that talks about this a little bit, but I just want to go into more detail. So this black line represents the 542 million year ago time frame, where before that there basically was no complicated complex life, and then after that we had this boom of complicated life. So no complex life and then complex life. Now then, looking at each of these, or like how you use this table. For example, if you're asked a question about Cryptolithus, it's a trilobite, but it's got a B on it. You look for B on the distribution timeline. You find it here. You're asked a question about Coleophysis. Obviously it's a dinosaur, but you find it here. Let's say you're asked a question about the condor. We did have a condor. It went extinct. Had condors in the state of New York. It comes up here. And then going back to thinking about corals, this is a coral. You look for T, and it's there. All right, and each of these has a class that's associated with it. So this, and it's sideways. The dark black line tells you when something came about and then left. Okay, when it went extinct. And then so trilobites went extinct. Dinosaurs, we know that, went extinct. This is their timeline. It's sideways, so it's a little bit challenging to read. Birds came about not that long ago. We haven't always had birds, but we still have birds, clearly. All right, we still have mammals, and they didn't go extinct yet. Anything that has a black line all the way to the present means it's still with us. It didn't go extinct. And then this Lichinaria is a coral, and corals, we know we still have corals. We still have them. They're not gone yet. That's how you use this time distribution of fossils site. So this one listed on the side, like brachiopods and gastropods, those are the class of the particular species. Sometimes you have 2, 3, 4 of that particular class of animal or plant. Alright, scooting over one more to important geological events in the state of New York. You have a variety of things listed here, but it's usually related to plate tectonic events, opening of seas, closing of seas, mountain building, just different things related to what happened on the land that wasn't necessarily, it's not about living things, it's about land things. So be familiar with this. You don't need to memorize this, but if you see something that's like a proper noun, the Adirondacks or North American African separate, Palisade sill, you don't need to memorize what that is. It's here on this column. Going a little bit more down, I want you to notice a particular word, orogeny, Alleghenian orogeny, and so on. The word orogeny means mountain building event. All right, and it affected, these particular orogenies impacted all of the East Coast. So the Alleghenian orogeny, for example, impacts North America and Africa, and there's evidence there. And when the mountain building event happened, that created Pangea. All right, so you'll see this little mountain here. That mountain is just to indicate mountain building orogeny. There's that term. I haven't explained that before, but you have other things here as well. Catskill delta forms, salt and gypsum deposits in evaporite basins. These are all related to evidence that you can see in our state. Okay, I'm popping over one more column, the last column, the inferred positions of Earth's landmass. This is just snapshots of what the tectonic plates looked like through geologic time. All right, and they shifted and moved, as we know from looking at plate tectonics, that they move through time. Sometimes they were all one big landmass, and sometimes they're all separate, like we are kind of now, all separate. Eventually we'll come back together again. The black mass here, the black here, 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 and here, anywhere you see the black, it says it, or it does, I don't think it does say it, that is North America. So that is where North America was through time. So Canada, the US, and Mexico, where it was through geologic time. And notice that it's shifted between above and below the equator through geologic time. And then thinking back about the Ordovician time frame and those corals that I pointed out before, we had corals back then because North America was basically overriding the equator. So this is the equator. I should have mentioned that before. And this snapshot is 458 million years ago, which is what we were talking about for that frame of time for the corals. Now, the homework that you're going to have this weekend is going to be looking at three-dimensional fossils. How can we do that? We can do that virtually. So I have an assignment that I'm going to give you, and it looks like this. So this is a site, it's called Sketchfab, and you are going to have some fossils that are on your reference table. Unfortunately, we don't have a Triceratops in our, we never had one in our state and haven't found one in our state. We have a dinosaur that was found in our state, but I do think it was just related to dinosaur footprints. So I have a footprint for you to look at, but this site is pretty cool. You can manipulate and look at a particular fossil in 3 dimensions, and I hope that you have a little fun with that. I tried it out on my phone, and I know it works on my phone, so it should work on yours as well, if that's what you're using. Alright, so if you have any questions at all, just let me know in an email. Otherwise, that's it. Have fun.